Okay, we're going to work a little bit more today with trig models. What's a trig model? Well, you know, trig models, of course. This model is actually named Twiggy. Twiggy was a very famous model back in my day. She was known for being so thin. She brought attention to anorexia, I think, actually. So a little bit of social math connection there. Add that to your TOK. We don't have any real new ideas here. We're just going to explore how we can use trig functions to look at real life data. And before, you'll remember, we'd given you a bunch of individual data points and you tried to find the trig function that matched those data points. This time, we're going to actually give you the model and just ask some questions about it and think about analyzing and interpreting the model. So here's the model, 3 sine pi over 6t, not a very complicated one. There's no shifts, it's just some stretches, and it's a simple sine model. So we're going to start by graphing it, and in this case, it's not even that difficult to graph, so I'm not even going to use graph paper, although this is going to look pretty ugly if I don't get this good. We see that it has a principal axis of 0, so it's going to go up and down around 0. So here's our x-axis right here. Actually, it's a t-axis, I guess. So t is going to look like that. And we have an amplitude of 3, so let's put 3 about here, and let's put minus 3 about here. There's no offset. Now we look at this pi over 6, and the period is 2 pi over 6. If we put the 6 up here, we get a period of 12. This is one of those 12-hour deals. So we'll make this 12 hours. We're going to go from 0 to 24. So here's 12, and 24 is over here, and we're going to have 2 cycles in that. Whoops, 2 cycles in that much time. So a sine cycle has a 0 in the middle, a max at the quarter, and a max at the 3/4, which is here. We'll do that again. 0 in the middle, a max at the quarter, and a max at the 3/4. And so we've got this kind of shape that looks about like that. Whoops, right through the middle there. Right through that. Don't miss. Right through, come on. Whoa. Not so great, but not bad. It'll do. That's about a graph. Sketch, I would call that a sketch more than a graph. When is high tide and what is the maximum height? Well, high tide is what? When is high tide? It's when the height of the tide. So when is high tide and what's the maximum height? The high tides are going to be here. There are going to be 2 of them, and they're right here, and they're going to happen. You can actually see it here. You don't have to solve the equation algebraically. We're going to see that it's going to happen here at 3 hours. Here's 3, and then again at these are hours after midnight. So this is 3 o'clock in the morning. This is 3 o'clock in the afternoon. Those are the 2 high tides. But let's go ahead and do that algebraically just to show you how we do that. We're going to say at what time is the height 3? At what time is this height 3? So when is 3 equal to 3 sine pi over 6 t, and divide both sides by 3, and we get sine of pi over 6 sine of pi over 6t is equal to 1, and that means the angle whose sine is 1 is pi over 6t. Well, the angle whose sine is 1 is pi over 2 as a sine of 1. So pi over 2 is going to be pi over 6t, and multiply both sides by pi over 6, and we get multiply both sides by 6 over pi to get rid of the pi's, and we get our 3. And that's, of course, only the first peak. The second peak is going to come when we add one more cycle, which is 12 hours to that. And And so we've got 3 here, and then 12 hours more is 15, or 1500 hours, which would be 3 o'clock p.m. You'll notice that when we have an angle of pi over 2, we don't have two values for pi for the angle. It's just pi over 2, as opposed to an angle like pi over 6. There would be another associated angle at pi minus pi over 6. All right, so that's that. Again, if you've got a nice graph, I would just do that graphically and not worry about the algebra, but I just wanted to show you how to do it. What's the height at 2 p.m.? Now this is a little bit more interesting. What's the height at 2 p.m.? Well, here's 3. We're going to come up here and look at, well, it's actually not that difficult. We're going to just plug in 2 for t, and we're going to have h of 2 is equal to 3 sine of 2 pi over 6, which is 2 pi over 6, which is pi over 3, and the sine of pi over 3 is root 3 over 2, so we have 3 root 3 over 2 exactly, or some number if you want to work it as a decimal and estimate it, but that's 3 root 3 over 2 would be this height right here. And part D is the kind of more useful one. If a ship can cross the harbor, provided the tide is at least 2 meters above mean sea level, when is the crossing possible? Well, we can see from the graph that the tide has to be above 2 meters. So, we have to have at least 2 meters of depth. So the crossing is going to be between here and here, and then maybe once again between here and here. So let's see, we're going to find the times. We need to find the times when h of t is 2. So when is 2 equal to 3 sine of pi over 6t? And now, since we're going to find multiple values, we're going to maybe work a little bit harder at this and use the 2 pi k thing. So 2/3 is the angle, or the arcsine of 2/3 is what we need as our base angle, and that's going to be equal to pi over 6t. Okay, so let's go over here. I need a calculator to do this, and pi minus that is 2.411 blah 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 blah. That's a 4. And then each of these, of course, is plus 2 pi k. So write those down there and keep track of them. 2k pi, that's all right. And now I need to multiply by 6 over pi. So let's get these numbers with 6 over pi multiplied by them. And the times, I'm going to go back, write those up here. So t then is going to be, let's get the calculator. And the first one becomes 1.39 blah blah blah, and when we multiply the 6 over pi times the 2 pi k, of course we get the period, which is 12. So plus 12k, that's 1.39 plus 12k, and the other one is 4.60 blah 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 plus another 12k. And now we need to just change these into times, so we want to take the remainder here, the 0.39, this is a decimal hour, and we need to take 0.39 times 60 to find out how many minutes that is, and likewise for 0.60 here. And for this first one, we get 0.39 hours is 23.6 minutes, or about 23 minutes. So we're going to get 1:23, 23 minutes after 1 in the morning, and then for the 0.6 here, we get 36 minutes, so we get 4:36 basically rounded. So our times are going to be right here at 1:23, and the second one is going to be here at 4:36, and those are both in the morning. And then we have to add 12 hours to each of those, and we'll have another time when it can cross between 1:23 and 4:36. in the afternoon. That's our plus 12. And that's all we need for the 1 day to just add one version of 12. And that'll do it. Okay, so that's pretty much it. We're just going to do some homework problems here. There's a couple of question banks. On those question banks, make sure you only do the parts that I've listed here. If you try to do 78D or 8E, you're going to find yourself in unfamiliar territory. These 3 problems that are from the book, they look like this. They're hopefully pretty straightforward. This number 5, spend a good amount of time on that one and really make sure you understand it. All right, have a great afternoon, and I will see you next time around.